Today we will be talking about cladogenesis and how it relates to phylogenetics. Phylogenetics is the study of relationships between different organisms and species based on common ancestors. In order to represent phylogenesis, we can use a phylogenetic tree like this one. To better understand what this tree means, we need to know some terminology. What we see here is known as a rooted tree, in which the distances between operational taxonomic unit is known. The order of divergence can be determined based on these OTUs. Each branch of the tree represents a different species, with species A being the outgroup. The outgroup is the species that diverged from the rest of the lineage the earliest. Anagenesis is the evolution of a species that continues over time. Anagenesis can be seen here, because there is no branching and we can see that this species is continuously evolving without interruption. Cladogenesis is the splitting of one lineage into two separate lineages, as we can see here on the tree. The two new branches then evolve separately from each other and can continue to branch and show further cladogenesis as time goes on. This branching causes internal nodes in the tree, as we can see at these highlighted areas. Internal nodes denote where differences in speciation occur and represent the last common ancestor of the two separate lineages. Based on this tree and what we know about OTUs, we can see that C and D are the most closely related species because their branches are the shortest. Now that we know how to read and gain information about a lineage based on its phylogenetic tree, let's take a look at an example using candy. Here is our phylogenetic candy tree. We can see that starbursts are our outgroup because they diverge the earliest from the rest of the lineage. This means that they are the furthest related candy from any of the others because starbursts have a fruity flavor, whereas the rest of the candies are chocolate. Now, if we follow our chocolate lineage, we can see that cladogenesis occurs at this split due to the fact that the top candies evolved to be in the form of bars and the bottom candies evolved to be bite-sized pieces. Following the bar lineage, the next cladogenetic branch occurs at this internal node as the top bars take on the characteristic of being crunchy and the bottom bars remain uncrunchy. The crunch bar separates from the Heath bar because the crunch bar contains rice and the Heath bar contains toffee. Next, the uncrunchy bars split into milk and non-milk chocolate. The non-milk chocolate splits based on being dark chocolate or white chocolate. As for our bite-sized chocolate, cladogenesis occurs based on if the candy contains additional flavors or not. Finally, the split occurs based on if the additional flavor is peanut butter or mint. By using this phylogenetic tree, we can infer a lot about a candy's lineage. For example, we can see that the most recent common ancestor between the Crunch Bar and Junior Mints can be found at this internal node, whereas the most recent common ancestor between the Junior Mints and M&Ms occurs at this internal node. Based on this information and on the OTUs, we were able to determine that Junior Mints are more closely related to M&Ms than they are to Crunch Bars.